Let's take a look at .NET assemblies. An assembly, in its simplistic definition, is the target of compilation. If I click Build and Build Solution, it is going to invoke the C# compiler, turning our C# code into IL code, which is intermediate language. So it is almost like another programming language that is built by the C# compiler. VB would do the same thing using the VB compiler. This IL code is now embedded in the application assembly. Because it's a console application, it is going to be an exe file type, so executable. This is also known as a process assembly. The other choice would be a class library style assembly, which would have a DLL extension for dynamically linked library. I can find this executable file by right-clicking on the project and selecting Open Folder in File Explorer. And then I can expand it, expand bin, which is where it puts the binary files or the compiled files, and select debug. I know it's debug not only because it's the only folder under bin in this case, but because that was what was selected as the solution configuration up here in the standard toolbar. Let's go back to the folder where we found assembly demo.exe, and you'll notice there are other files here as well. We can ignore the last three files, which are virtually identical to the first three, except they have this VS host extension before the true extension of the files. And that's just the indicator that these are specific for the Visual Studio hosting process. And when you're running in Visual Studio, it'll utilize these as opposed to the top three. Now the top three files are the ones you would actually distribute to a client if you were going to install it. The first one is the actual assembly. This assembly demo.exe is the assembly file. You can create multi-module assemblies as well, but that has to be done on the command line, not through Visual Studio, or at least not without plugins to Visual Studio. Typically then we will have a single file corresponding to an assembly. There is a config file associated with this exe as well, and that config file contains information specific to this executable, and by default, if I double click on it, you'll see it has very little information, just indicating what runtime is supported by this application. You will also see a PDB file, which is a program debug database file, which is used by Visual Studio and the CLR when debugging, so it can tie the source code lines to the IL code that is generated by the compilers. Let's go back to the project and take an in-depth look at what the assembly is actually composed of. As we know, the assembly has a name, but there are actually two different names to an assembly. It's the common name, which is also the same as the namespace, assembly demo in this case, and then there is the fully qualified name, which has three other pieces of information to uniquely identify it. Let's take a look at those. If I double click on the properties node, it'll bring up the property page for the project. I could have also selected project from menu and selected assembly demo properties as well. Brings me to the same dialog. If application is selected on the left, then you will see the assembly name text box here in the top of the dialog. That corresponds to the common assembly name, or the one that you would typically refer to. This is the assembly demo assembly. And you can also see that the default namespace has the exact same name. That is a function of the template that generates your projects. It will make the assembly name and the namespace the same by default. If you change the default namespace, just be aware it doesn't change the existing namespace declarations in your code. So program.cs has this namespace declaration, changing it here will only modify future or new classes that you add to your assembly, not the existing ones. So if you do change the default namespace and you intend for all of your classes to be in that new namespace, you'll have to modify the existing ones. But that's not really part of this conversation. I just wanted to highlight that while we're here. I do want to click on this assembly information button though. Here we're going to see other information such as the assembly title, description, company, product. This is all metadata associated with the assembly, which is part of the assembly file itself. So along with the IL code, you will have this information. This is just a convenient dialog that wraps the assembly info CS file, which you can find under properties. If I expand properties, you'll see assembly info CS, and essentially you see the same information. These are all attributes. Assembly title is actually assembly title attribute, but you don't need to type in that last attribute name. The compiler and C# understand if you leave that off, you still mean the same thing. And then you have description, we have title, description, configuration, company, etc. Pretty much the same as what we saw in that other dialog. All of these attributes are targeting the assembly. That's what that assembly colon at the beginning of the attribute name is. So instead of targeting the next thing, like when we did flags enums, you would type flags just in front of the enum definition, and therefore the flags apply to that next thing, which is the enum. This doesn't have anything following it. It's just a bunch of attributes. So it can't apply to anything specific unless we target it like this, saying, well, this particular attribute applies to the assembly level. So that's how come that's there. It doesn't matter if you modify it within this file or the dialog, this information. It basically goes to the same place when you compile it. So I was saying an assembly name is actually composed of 4 different things. I already said it's the assembly's common or short name. We also have the culture of the assembly. Notice that it's left blank here. That means neutral culture. And as a matter of fact, for executable style assemblies or process assemblies, it should always be neutral. This means that it doesn't get tied to a specific country or language. It is for any culture. So the rule of thumb is for any process style assembly, just leave it as neutral culture and only use satellite assemblies with specific culture information. So that's part 2 of the assembly identification. Part 3 is the assembly's version number, which you can find at the bottom of assemblyinfo.cs. As you can see, it's 1.0.0.0 to start with. The first number is the major number, the second one's minor, then you have build number and revision. And each one of these are typically maintained by the organization that's building the application. So you don't want to just haphazardly change these version numbers at will. The 2 most important ones to maintain some kind of stability are the major and minor. You can think of like the Windows operating system has version numbers, like we had Windows 8.0, then 8.1. Those are the ones that people will identify with. And those are released not as frequently as possibly build or revision numbers. These build and revision numbers are typically interim builds, like if you have a service release or a service pack, then you'll typically crank up the build number. And revisions are typically done internally, like you have maybe 20 or 30 builds, like maybe nightly, between build releases. So you might crank this last one up much more frequently than you would the build number. But this is not a standard by any stretch of the imagination. Everybody can define their own regiment for incrementing build numbers. That was the third piece that identifies an assembly. The final one, if it's a strongly named assembly, will also have a security certificate associated with it. It's kind of like encryption or signing of the assembly. This certificate guarantees that the assembly comes from who it says it comes from. So Microsoft has their own internal certificate they use to sign their assemblies. So they'll all usually have the same public key token. And it is not the actual key used to encrypt or sign the file. It is basically the token that represents it. It's kind of like a fingerprint. Now, this is not a requirement of your assemblies, and we'll have a specific discussion on creating these strong named assemblies. For right now, we'll assume that there is no certificate associated with our assembly, so it's not going to be a secured assembly. So assembly demo here in the title, we can change that. Maybe you could put a space in there. You can put a description. This is a demo assembly configuration. If you have any specific configuration information, I might want to say that this is a debug build, so I can type in debug here. If you have a company, you could put it in here. And we can fix the copyright if necessary. If we want to change the product name, if it's different than the title, we can just name it Assembly Demo. If there are trademarks associated with it, and again, we leave culture neutral for an executable. If I rebuild this and I go to the File Explorer again, once the build is complete, I can right-click on that executable file, go to Properties, click Details, and you'll see some of that information here. So you see I changed the description to assembly space demo. The file version number, or the assembly version number, is 1.0.0.0. We have, again, the product name. And we also have the language which specifies neutral, which is what we intended. If you did decide you wanted to change the assembly culture to something like ENUS, you'll see that the compiler and IntelliSense are going to yell at you saying that this should have nothing in it, essentially. So make sure you leave that blank prior to compilation. Let's go back to our code and add a couple methods, just so we can see what the resulting IL code looks like. So it'd be fun to take a look at what the IL code is, since we already know what the C# looks like. Let's say private static void print me. It accepts a string input. And then we can do a console write line of the input. We can also do, no, not public. Let's do private static. There's no reason to put public at this level because nothing is going to access this outside of the program class. Don't suppose it would hurt. So we'd have private static void double me. Oh, let's make it actually, instead of printing it, let's return an int. We'll have input. Then we can return, better yet, let's make a variable so we can actually see that in the IL code. Call int result is equal to input times 2, return result. Let's rebuild this. And now I want to bring up the IL disassembler. To find that, you'll have to go to your Windows menu, and depending on what kind of configuration you have, this is Windows 10, so it may look different than what you have, but I'm going to select All Apps, and then I will navigate down to Visual Studio 2015. Don't pick the icon with the infinity symbol, pick the one that has a folder, and from here you want to find the developer command prompt for VS 2015. It'll look like a typical command prompt, except it's going to have additional path information assigned. So when I type in ILDASM, it'll be able to find that program. I'm going to select File and Open, and then I have to navigate to the place where my project is, and you can see Assembly Demo is under my Visual Studio 2015 Documents folder, Projects, Assembly Demo. Select Bin, Debug, and then assemblydemo.exe. And now I'm going to click View, Show Source Lines. That way when I look at the source code compared to the IL code, I can see what it started with and what it generated. You can see down here it shows the assembly demo as version 1.0.0. I can click on the manifest or double click on it. And in there you're going to see things like that assembly title and the description, all those things you saw in Assembly Info CS. Now it's going to be displayed as hexadecimal, but the good news is it shows to the right of that comments what it looks like in English. Okay, let's go ahead and close this window down. And then this assembly demo represents the namespace, and then we have our program class in there. And inside the program class, you can see it has a constructor, which we don't see because it's something supplied by the compiler since we didn't provide one. We have our double me, main, and print me methods. Let's just double click on print me, and then you will see the IL code for that method. And with every line of code, you will see a comment corresponding to the source code because I had that view source lines checked inside of the view menu out here. So show source lines. So even things like the open brace and the close brace are commented here as well. So here's the IL, and each line of IL is preceded by a label. This is not specifically tied to the line numbers of the generated code. It just is a convenience that was put in place by the C# compiler. So we have like IL line 0, which says NOP for no operation. Then line 1 is loading argument 0. This is like assembly loading a value into a register. Then it makes an external call to the console write line, and it passes to it a string, which is whatever was loaded in that argument here. So it's basically passing argument 0, which corresponds to the string. Then we have no op, and then finally a return. Now the no operations literally mean no operation, and it is sometimes put in there just so there is a label that can be jumped to without executing any lines before it. So if for some reason the code needed to do a hard jump to the end of the method, it could jump to this label here. Or excuse me, it could jump to this label here, which is just before that close curly brace. So there's no actual execution of any code on this line, so it's a safe line to jump to, which will allow us to exit this method. And as you can see here, this RET corresponds to the return command, which we don't issue explicitly because it's a void method, so that is something supplied by the compiler. You'll see very similar code in the double me method. It's a little longer because we create a temporary variable, like this int result being equal to input times 2. So that's where it loads in the values, the first argument, which is going to be input, and then we have loading an integer value, 4 bytes, and it's putting in the value 2, and it multiplies them together and stores the result at this location. And that corresponds to the result variable, which is then returned. So you can see just a couple lines of C# code. This int result equals input times 2, and this return result ends up generating quite a few IL instructions. That doesn't mean it's slow. Most of these can operate either in a single clock cycle or multiple lines in a single clock cycle. It just depends on what operations are being performed. So that's what the IL code looks like. And most of the time, it's nice to know it's there and it's cool to look at, but you're never really going to have to manipulate that directly. It's actually frowned upon, although there are people out there that either make a living or it's a hobby generating .NET compatible code using just IL instructions.